Hey guys, so today you and I are going to talk about rewriting systems. So let's get into it. So the question in question was, Frederick, how do I rewrite a huge old system into new technologies? Well, there are many ways of doing this. The way that I like to think about it is that if your huge old system is a spider web or like a knot of strings or something like that, now the real work sort of for you is actually just to figure out where all the threads are and where they lead and how they all interconnect to each other. That's number one. And then the next thing is to do what I call feature matching. So let me explain that a little bit. When you are moving from one tech stack or one set of technologies to another, and in this case it's a rewrite, which means that you're sort of starting fresh in a sense. The number one thing for you to figure out is how all the pieces of the old systems are connected to each other. That's number one. Because what you want is to do is or rather this is what I suggest that you do, because this is the way that if we think about this in a little bit of a computer sciencey way, a topological order is very, very important to consider when you're dealing with a system, such as a network. And most software all software is a network, all of it. I don't know if you ever thought about that, but everything in your program is part of a tree structure. It's not a perfect tree, but it's always a tree. There's an entry point, and there might be multiple places where there's like an end node somewhere on the tree or something like that, and then if it's a web application, there is a response. The same thing is true for in a distributed system, it's more of a graph, but the same sort of rules still apply. You might have multiple entry points into the graph, and then everything is sort of connected in one way or another. And the trick is to figure out where, as I call, the leaf nodes are. Why is this important? Well, I'm glad you asked, because the leaf node is the thing that you could move from this complicated structure of like interconnections and dependencies and so forth, and still maintain the old system. This is very significant because now you can take one of these dependencies. Let's say something simple. You have a service, you have something that stores something. It's a small part of the system. It just handles some type of like storage, etc., etc., for the larger system. Well, this is something that might just have one connection to the main system, and because it doesn't have so many connections, it's actually very easy for you to figure out, all right, how do I move this thing into a new technology? So you can actually do, as I said, you can do feature matching. Oh, there's just a few features here. Let's rewrite that in, let's say, a new language or something like that, or create a new service in a new tech stack. And then when you have done that, you can do a blue-green type of thing, or there's many ways to do this. You can, depending on how large it is, put an interface or like a gateway in front of this service, or if it's just code, it's just an interface, and say, all right, I'm just going to match the interfaces towards the main system, and then I'm going to switch over. So the old thing goes into sunset mode, and the new thing goes into, it takes over the load. And then you sort of look and see, how does this work? And if it works really well, that means that you now have a new node in the network. You can still keep the old one just to make sure that you can roll back if you needed to. But there you are. You just took one leaf from this old system and converted it into something nice and new without much of an impact to the main system. But what now happens, which is very interesting, is that now the downstream or upstream, depending on how you look at it, node, the next thing that this thing is connected to, just got unlocked, if that makes sense. You have now gained the experience or the necessary insight into how the next thing is connected, and now you can follow that strand and connect and you switch out the next node in a similar sort of fashion. And this is why, as I like to say, going depth first. If you think about graph theory, depth first is definitely the way, in my opinion, how you rewrite a large system, because you have to pick something, and you can't rewrite the whole thing at the same time. And the larger the scope is of the rewrite, the more likely you are to make a mistake. So the reason why you want to just start at one little node is because it's actually very simple for you to do a meaningful change, get a proof of concept, get some learnings, and then figure out what the next natural step is, which is probably the next node in the network. And then you move that into a clean structure. And that is why I can make the analogy to following a strand, like a thread or something like that, in a spider web or a very complicated knot, because that is, you just take the end of a thread and you just follow it until you've gone through the whole thing, and when it's nice and clean and straight, and you just like decouple it and you can put it to its side, then you have an entire thread of functionality that is now in a clean state. It's like well made, etc., etc. And if we talk about mental pictures, the goal is for you to continue that process until you go from having a ball of like all these interconnections to something that sort of looks like just a stack of threads that are just lying on the table and not a knot anymore. That's impossible, but I hope that you sort of get what I'm looking for. You're just taking one strand, putting it in, like moving piece by piece, and making sure that the interfaces stay compliant. That's that's a combination of, as I like to say, the lift and shift, which is the idea of, you just lift functionality and shift it over to a new structure or something like that, and doing basically a topological, attacking a problem in a topological order, and that's really all there is to it. The reason why I prefer to do it the lift and shift like this, because it's sort of like the idea of is it Martin Fowler? Having one hat at a time. You don't want to rewrite the system and refactor it at the same time, because it's very difficult for you to see both how you're going to move things in a complicated structure and at the same time figure out how the new architecture is going to look. That's why the moving like this is so useful, because you can focus on one leaf which has one connection. Remember now, it's just connected into one other thing, which means that you can get a very clear picture of how that interacts with the next thing and how that fits into the overall structure. And when you have moved enough stuff, you're going to sort of figure out, okay, because you always do that, right? You always design the whole thing in your head to a certain point, but you will now be able to sort of, without making any change to the current way things are working, figure out if that architecture, that theoretical architecture you have, is that actually the way to go, yes or no? Because the problem with like the old waterfall system, which is like you basically plan out everything ahead before you even touch any code, is that you don't know. You haven't tried stuff out. You have actually, in many cases, you basically just mentally picture the wrong thing, because humans are flawed. It's very difficult for you to do in a big system to figure out how everything fits together and what the right interface is and the right architecture is going to be, etc., etc. It's ludicrous to do it, honest to God. It's been proven over and over and over that this is an ineffective way of doing something like this. And that's why if you do it this way, you might not be able to say to your stakeholders on day one, yeah, this is how the end thing is going to look like, but you're going to be able to start cleaning things up and get value immediately while building up the necessary context and domain understanding to actually answer those questions a little bit further down the line. And there's really no risk. It's sort of like a journey of discovery where you're sort of just cleaning things up as you go along without changing much in terms of functionality. But it gives you the necessary information to know, when you've moved out all these threads into a nice clean structure, how do we reimagine the system now? Because now it's fresh in our heads, we've just touched everything, we've sort of traced all the complexities and all the areas that are not so nice. Now you can create technical roadmaps, you can create a new way of, like, you can merge services, you can move them around, split them out into new services. All that discovery, all that learning came without any risk to the overall project, without any time delays, because you still needed to refactor everything like that. And all you really did was that you split up the reimagining of how the system should work from the migration to a new stack. and you used an approach which allowed you to, in a very safe and isolated way, move each piece without any real risk or impact to the overall system. So what I want you to take away from this is that the way that I usually rewrite old systems is that I do a lift and shift, which the idea is basically you just take the system as is right now and look at it. All right, I need it to be in this new tech stack or in this new thing, right? And then you basically move it as is, practically, to the new structure. While you're doing that, you take note of all the things that are how things are working, because now by just doing this pure refactor, you're actually learning things about the code base. And then when you have done that, it becomes fairly easy for you to change things, reimagine things, etc., etc. And it's very as I said, if you just go about it by using a topological approach, where you go to the leaf node in your topological dependency tree or graph or whatever, and pick the leaf, then that is always the easiest thing. And if you pick one leaf, well, then you now unlock the next leaf, and then you pick the next leaf and the next leaf. It's a depth for search type of a deal. You just pick an arbitrary thing, start pulling on the thread until it's all out of the yarn, like the spider web of the strings, put it to the side, pull the next one, and continue until you have moved everything, and now you actually know how the whole, well, in essence, you know how all the pieces work, and they're now in a clean, nice working state, where it's sort of like a carpenter or like a craftsman preparing his or her materials. Now, instead of this yarn of spider webs that's sort of difficult to make something meaningful out of, you have this clean little structure where you can go, all right, cool, how do we now recreate this in a much better way than it used to be? Always works for me. Have a great day.